Select the major product that forms from the following series of reactions. So we are starting with, we can see that we have a secondary alkyl halide. And we're going to consider what the secondary alkyl halide does in this first step, and then we're going to want to draw the product of that step, and then treat the second step as a separate reaction. So we're basically stringing together two one-step reactions, and you're going to want to draw out products when you come across something like this. So the first thing we're going to do is look at that secondary alkyl halide. And so we've seen alkyl halides undergo substitution and elimination reactions. And we definitely see some substitution and elimination products as our possibilities, so we want to be thinking about these. So if we look at what we're reacting with first, we've got sodium iodide. So if we think about iodide, which is really the reagent here, the sodium is the positively charged counterion. So we'll draw it in, but it's really the iodide we need to think about. Iodide is the conjugate base of a really strong acid, so it is a really weak base. But it's a great nucleophile because we have this large electron cloud. So this is a good nucleophile. And you might see in your textbook that how good of a nucleophile that iodide is depends on the solvent. We're not going to get too specific into that. We're just going to recognize that it's a good nucleophile and a weak base. And what we wanted to put together is that with a good nucleophile and a secondary alkyl halide, we are looking at an SN2 substitution. Okay, so that is your concerted substitution. So that means that when we draw our iodide and it is attacking the carbon where we have our leaving group, it's doing so all in one step. So we have our iodide is attacking and it's pushing off the chloride. So in order to do that, it basically has to come up from behind the chloride and push it out of the way. So that means if this chloride was on a dash bond going into the plane of the page, the iodide is approaching from the top. So it's going to end up on a wedge bond as a result of that SN2 reaction. Okay, so we're going to make sure we put the chloride on the wedge bond. And now you might be noticing, well, what about that other chiral center next door? And there certainly is another chiral center next door. So that chiral center, if we look, nothing is happening there. We don't have anything occurring. So there's no way that the bonds to that center would change. So that methyl group was on a wedge. It's still on a wedge. Okay. So we can see that that is the product of step one. So now we want to consider the second step, right? So step one was with the sodium iodide. So we should actually be drawing iodide and not chloride. So quickly fix that into an iodide. And I'll clean that up a bit before we move on. Okay. So we still have an alkyl halide. We just have a different halide. We have iodide. Okay. So now we want to consider in the second step, we're treating this with NaSH. So again, we want to recognize that sodium is the counterion and the negatively charged sulfur is what's going to be our nucleophile or our base. So this is a weaker base than hydroxide because it's a larger atom. It's better able to stabilize that negative charge. So this is again a really good nucleophile. And again, a secondary alkyl halide, just a different one. So we are still looking at an SN2 reaction here. So this is still going to be SN2. So now we want to take a look at this sulfur approaching then 180 degrees away from that iodide. So we can draw our sulfur. And it's approaching from 180 degrees away from the iodide. So if the iodide's sticking up, this is actually coming from behind the plane of the page. So the bond to the sulfur is going to end up on a dash bond. And again, that chiral center next door still hasn't changed. So what we've seen here is that we do two consecutive SN2 reactions. So this is SN2, this is SN2. So in our first step, the SN2 reaction inverts the chirality, and in the second step, it inverts it again. So the overall result is it looks like we've retained the chirality from the starting material. So we're just going to pick that out of our options, and we can see that that is A. Okay, so if we wanted to get our other substitution product D, we just wouldn't do that first step. We would just take our starting alkyl halide, treat it with our NaSH, and we would have gotten to D.